So quiz 7, we kind of jumped around in the order. I keep meaning to change the order and numbering of these quizzes. We'll go with my good old favorite student, good old Anne. So we talked way back at the very beginning of this about period and frequency. Remember the ticker tape lab that we did? Those clicking ticker tapes, very, very loud, very, very annoying. In fact, I think one of our friends had a concussion that day, and I had to laugh because it was exactly the worst possible lab, maybe in history, to be doing when you had a headache, but I found that humorous because that's how I roll. What's the period? What's the frequency? So frequency is the number of what? The number of times per second, the number of cycles per second. So the frequency is going to be whatever the heck 480 divided by 45 is. .7 hertz, 10.66, 10.7, and the units are hertz. 1 mark for that. The period, well, it's 1 over the frequency, so one way of doing it would be to go 1 divided by that there. By the way, this notion of 1 over is so common, most of your scientific calculators have a reciprocal button, a little x to the -1, and so, wrong button. You could just go like that if you're really, really lazy, and that says, I'll take the reciprocal of the answer. And the period is 0.09375. Or you could have gone 45 divided by 480, because period is how long it takes to do it once. So if it takes 480 seconds to do it 45 times, if you divide, you also get 0.09375. 0.09375. I guess 0.094. Really, for both of these, I should go to 2 sig figs. Really, I should have said 11 hertz, and I should have said 0.094 seconds, but I won't be fussy on sig figs. 1 mark for each of those. So you know what? Probably on your test, I'll ask you to find the frequency. I'll ask you to find the period. 1 question, only once, because I didn't do a big song and dance about it. Number 2 is trickier than you think. Number 2 says how far, so they clearly want us to find a distance. They gave me a velocity. Does this question mention an acceleration at all? Then we assume it's 0. What's the time? Not 2.5. Or it is, but what don't I like about that 2.5? Okay, it's minutes. Once or twice on the test, I am going to give you a time in minutes or hours. So how do I go from minutes to seconds? We did some unit conversion way back in the day. This one you might just know. What were you going to say, Spence? It's times by 60. If you blanked, you could say, I want minutes to cancel. I want seconds to be, 60 seconds for 1 minute. The minutes cancel. So you could use that fraction chain, what we call dimensional analysis trick. But most of you know 1 minute, 60 seconds, 2 minutes, 120 seconds. I think I multiplied by 60. 2.5 times 60, 180? No, that's wrong. 150? And now I can use now, technically it's VI, but since there's no acceleration, VI is VF, is V, is V average, is... So anyways, it's going to be 12 times 150. Do that one in your head, Mr. Dueck. Okay. It's going to be 300 times 1,800? Yeah? 1.8 kilometers. By the way, 12 meters per second, that's a pretty fast cat. But think about it. That would be, this room is about 10 meters wide, give or take. So that would be the cat running across in a second or less, which is pretty fast. A racing car travels 560 kilometers. Oh, part marks, Mr. Dueck. If you got the right answer, obviously 2 out of 2. Otherwise, I'd probably give you 1 mark if I saw D equals VT. I'd probably give you 0.5 for doing the conversion and 0.5 for the answer. If you missed the conversion, if you went 12 times 2.5 and got 30, and you said that was 30 meters, I would probably give you, I don't know, 1.5 out of 2, and I'd say, for Pete's sakes, read units properly. Is 12 times 2.5 30? I think it is. Racing car travels 560 kilometers in 3.2 hours. Calculate the car's average speed in meters per second. Well, first of all, what do I measure speed in? Meters per second. What's the other unit we use on the roads? You know what? I think it's going to be 560 kilometers divided by 3.2 hours. That's how you get a speed in kilometers per hour. Why did I say average speed? Well, this is a road speed. I know, Cam, having driven on the road, my car speeds up, slows down, speeds up, slows down, speeds up. And I didn't want to try and get into all that. We talked about the notion of instantaneous speed, where we laid our ruler down on the curve and kind of eyeballed what the slope was. So 170, holy smokes. That's kilometers per hour. How do I change kilometers per hour to meters per second? Okay, so you're at the stage where most of you have memorized the shortcut. It's divide by 3.6. I'll do it the long way for those of you that have forgotten. The long way would have been to go 175 kilometers per hour. We would say, I want hours to cancel. I want seconds to be left behind. 1 hour is 3,600 seconds. And I want kilometers to cancel, so it goes on the bottom because kilometers is on the top. Oh, and by the way, the reason hours went on the top is because hours was on the bottom in the original fraction. And I want meters, and I would say, oh, 1,000 meters is 1 kilometer. And by the way, 1,000 divided by 3,600, that's where the divide by 3.6 shortcut comes from. 48.6 meters per second. Which is far more than speed legal. About 90 miles an hour if you're trying to get there. 48.6? Yeah. How many sig figs? Technically 2, so technically 49 meters per second. If I was marking this, I would probably say 1 mark for that. I would probably say 1 mark for that. And to be honest, I'd probably give you just 1 mark for cluing in that it was distance over time with no acceleration. Something like that. I don't know why it's 3 marks. To be honest, I'd make it worth 2 marks. On your test, there are going to be a couple of questions, let me emphasize that again, Natalia, where the units don't match. And inevitably, kids lose marks because the question seems so easy, but if it's worth 2 marks, usually that means it's a 2-step. There's a conversion or something. Number 4 is pretty tough. 3 marks. On a certain day, sound travels through the air at a speed of 340 meters per second. You shout while facing a distant cliff, and 8.6 seconds later, you hear the echo. Calculate the distance to the cliff. Okay. Right? For sound, what's the acceleration? 0. What's time? Well, it depends on how you want to do this. So if you use 8.6, your distance is going to be twice too big. Watch your language. Why? Because that's the time to go there and back. Right? Yeah. So you can use 8.6, but your distance you're going to have to divide by 2. Or you could say, I'm going to divide the time by 2 right now, 4.3, and go straight there. It's going to be D equals VT. What happened to the plus a half AT squared? What's A? So what's a half AT squared? 0. Going to be 340 times 8.6 By the way, I always do this one on purpose because every time there's someone who mutters under their breath and they realize, I'll never fall for that again, right? So what was it, 2,924? But that's so the actual distance is 1,462 meters. If you got that, that gets you 3 out of 3. Otherwise, 1 mark, 1 mark, 1 mark. So if you didn't divide by 2, if your answer is too big, you get 2 out of 3. Okay. By the way, you can do this if you're ever at a cliff where there is a good echo and your phones all have stopwatches. If you want to find out how far away, wherever that cliff is that your sound is echoing off of, time it, divide by 2, and if you really want to, although I guess all your phones have calculators now too, I always know that I've memorized that the speed of sound is 333. It's not quite right, but I remember the speed of sound is 333, and that's an easy number for me to remember. And you can find out how far away the cliff that you're echoing off of is, which is kind of nerdily cool. No? Okay, whatever. 5 is also tricky. I threw a bunch of weird questions on this particular quiz. A girl out for some exercise jogs at 5.1 meters per second for 1.5 minutes. I'm not a big fan of that. I'll have to do a unit conversion. And then walks at 2.5 for 12 minutes. Find her average speed. This question has jogging. A walking, and then an average. So jogging, well, the speed is going to be distance over time. Does this question mention an accelerate? You know what? I went too fast. I lost some of you there. The speed is going to be d equals vt plus a half at squared. It's really vit. But what does this question, Jordan, mention any kind of an acceleration? Say no. So you know what? This whole thing here vanishes. Whoop. So how would I get the v by itself? Divide by t. For both of these. So it's going to be the distance over, sorry, what am I doing here? Mr. Dueck, I got a problem here. I'm reading this wrong. They gave me the speed. They gave me the time. I think what I need to find is the distance. Here, they gave me the speed. They gave me the time. I think what I need to find is the distance. Boy, that was a bad start, Mr. Dueck. Yeah, I had a 4-day weekend. No, I had to work yesterday and Monday. Why do I need that? Well, average speed is going to be total distance, total time. How far did you go? How long did it take? That's your average speed. And that, Cam, lets us deal with the slowing down, speeding up, say, of cars or whatever. So the distance traveled here is going to be 5.1, 1.5 minutes. How do I change minutes to seconds? What did we say a few minutes ago? No pun intended. Okay, so it's going to be 1.5 times 60. The distance the girl jogged, (459 meters, I think. The distance that she walked, 12 times 60. 2.5 times 12 times 60. She walked 1,800 meters. So her average speed 1,800 meters, distance total. Nope, that's not right. 1,800 meters plus 459 is the distance total. How long did she jog for? 1.5 times 60, 90 seconds. How long did she walk for? 12 times 60, 720 seconds. So this is going to be her average speed. I'm going to have to ask her use brackets on the top. And I'm going to have to use brackets on the bottom. Average speed was 2.8, 2.79 meters per second. If I was marking this, I'd give you 1 mark if I saw that, 1 mark if I saw that, and 1 mark for the answer, probably something like that. That's a tricky one. Relative velocity. How do I know it's relative velocity? Because I see 2 things moving. A rabbit and a wolf. What do they want me to find? How long? The distance, apparently, that we have to make up is 12 meters. And we've said to solve these, use the relative velocity. What's the relative velocity here? How fast is the wolf traveling with respect to the rabbit? 6. I've told you that if it's a relative velocity question, I'm not going to give you an acceleration. Yeah. Velocity is actually 8. Both of us are in a slump. Not your day-to-day? We'll get you there. Velocity is actually 8. Thank you. So I'm looking for an equation that has all these in it. It's going to be our old friend, where a is 0. To get the t by itself, Jordan has already pointed out it's distance divided by velocity. So it's going to be 12 divided by 8. 1.5? Is that right? 1.5 seconds until lunchtime. In terms of part marks, I would probably give you 1 mark if I saw that you could successfully calculated the relative velocity of 8. I'd probably give you 1 mark if I saw that, 1 mark for the answer. But again, if you got it right, we're good. By the way, I like number 6. I like number 6. I like number 6. Number 6 is a nice question. I love number 7. I love number 7. I love number 7. Number 7 is a nice question. Now, number 7, this is the reason, by the way, I'm not going to officially count this quiz. Normally, because I gave you one like this in the homework, normally I go over this question before the quiz, and I just couldn't fit all that in with the long weekend and the block schedule and all that. So you ready, Colin? What are they asking me to find here? Okay. You okay with that? Are there 2 objects moving in this question? You know what? I think what I'm going to be able to find is the relative velocity. So I'm going to write VREL equals question mark. Okay. What's the distance here that we're trying to make up?
180 meters.
With me so far? Did they give me a time?
Yeah.
How much time?
1.8.
Oh, and what's my acceleration in a relative velocity question? 0. 0. I think right now we can go then right? And I think we can say, now this is going to be a relative velocity that we're finding. It's going to be the distance divided by the time. It's going to be 180 divided by 4.8. And I get, Colin, a relative velocity, 37.5 what? Units. It's meters per second. What that means, Colin, is this car has to be, the police have to be going 37.5 meters per second faster than the bad guys to catch up. Except, what did I want the final velocity units to be? Okay, so the first thing I'm going to do is I'm going to convert this to kilometers per hour. Okay? There's step one. How do I convert meters per second to kilometers per hour? I'll give you a hint. It also has something to do with 3.6. Times by 3.6. So the relative velocity in kilometers per hour is you okay with that? That's how fast the police have to be going relative to the bad guys. Now, that's if the bad guys are standing still. Are the bad guys standing still? How fast are they traveling? Okay, so the police is going to be 135. That's what would give you a relative velocity of 37.5 meters per second, or 135 kilometers per hour. Can I do this somehow? Yeah, they got to be going a pretty sterling 295 kilometers per hour, which is right on the threshold of being able to do it. Probably not with a cop car. A Formula One race car could probably pull that off. I was making up numbers just to try and get nice answers, but not reasonable answers. Okay. How many marks is this one worth? How many kind of sections of work did I do? Hey, that's an odd coincidence. I would probably give you 1 mark for finding that, 1 mark for the conversion, and 1 mark for the answer. There is going to be one something like this on your test, because A, it's cops and robbers. It's kind of cool. And it kind of ties everything together. Okay? But yeah, probably these bad guys are going away. Or, again, the issue is they're trying to catch up in 4.8 seconds. If they're trying to catch up in 30 seconds, they don't have to go so fast. They just have to go a little bit faster than the bad guys, right? So normally I would say, hey, give me a score out of 19. This is purely for your own studying and edification. Okay? So looking at the relative velocity homework, number 3 is a question that I kind of liked and I didn't talk about that I said I would talk about today. Do you think you can figure it out now, having seen a very similar question on the quiz? I think on the quiz it's almost identical. I just changed the numbers. Oh, except I think this answer is much more reasonable, I think, because I gave them 10 seconds to catch up. Were there any questions from the relative velocity homework that you wanted me to go over? Now is your chance to ask. Okay. Then last day, Cam, you got a copy of this, by the way? Yep. You did? Okay, good. Last day I handed out, I think, this great big velocity and acceleration unit review. Right? Yeah. Who does not have a copy? You got a copy of this one too, Cam? You the man. Oh. Okay. Your detention's going way down. I like you again. You don't have a copy? Were you away? Oh, you missed out. Questions that I like. I like number 1, I like number 1, I like number 1. In that, you're going to be asked to do some conversions, but not specifically as a question. There are going to be a couple of questions, though, where I give you the speeds or ask for the speeds in kilometers per hour. After that, pretty much for the remainder of the year, I'm going to give you proper units because most of the other stuff that we look at is measured in metric units anyways. I like number 2, I like number 2, I like number 2. I like number 5, I like number 5. I like number 6, I like number 6. I like number 7. I like number 7. I like number 7. Let's talk about number 8. Remember, for number 8, first of all, it's a displacement versus time graph. So when it's asking you for the displacement, where does displacement appear on a displacement versus time graph? It's meant to be really obvious, maybe so obvious that it's tricky. The displacement is your height, right? How high you are. In other words, when it says, what's the turtle's displacement at 2.5 seconds? 2.5 seconds is right about there. It's at negative 2.5, 2.6, I don't know. But it is negative, and it's just below 2 and just above negative 3, somewhere between negative 2 and negative 3. So that's to find the displacement. Then when it talks about, distance, that would be the scalar version, the same answers as number A, but none with any negatives. Total distance, well, you think about average speed and average velocity. Remember, that was when we laid down a ruler, and when we drew a tangent line, that would be the instantaneous or the average speed there, using tangent lines. I'm probably only going to give you one question like this. In fact, I think what I'm going to say to you is, I like D and I like E. Doesn't mean you don't need to try the other ones, but I like D, I like E, I like D, I like E, I like D, I like E. Okay. I like number 5, I like number 5, I like number 5, I like number 5. If you turn the page. Okay. In other words, you can expect that I give you some kind of a graph better than this one to analyze. Probably a linear graph or something like that. So what kind of a graph is this? It's speed versus time. Where does acceleration appear on a speed versus time graph? Slope, the slope. Okay? So when it says, what's the average acceleration? The only one I'm going to say I'm not too fussy on, you can cross out C, I think. Six, I like. 6, I like. 6, I like. Number 7, you can cross out D. You can cross out E. And you know what? You can even cross out C. So 7, A and B. Eight is good. 8 I like. You can cross out 9. Cross out 12, please. Cross out 13. If you did them already, that's fine, but these are not questions that you're necessarily going to see. 14 is fair game. 14, sorry, you know what? Cross out 14 because I don't like the units kilometers per hour per second. That's another way to measure acceleration, but that to me is a really, really sloppy way. 15, you can nuke. I like 16, I like 16, I like 16. 17, you can nuke. And then there's some of the answers, and then we get to the acceleration review, which is the next part. One is good. Here's like a relative velocity question. 2 is good. I like number 2. I like number 2. I like number 3. I like number 3. I like number 3. I like number 4. I like number 4. I like number 4. I like number 5. I like number 5. I like number 5. Six, you can cross out D. You can cross out E. You can cross out F. You can cross out C. You know what? 6, A and B. I like number 7. I like number 7. I like number 7. I like number 8. I like number 8. I like number 8. I like number 9. Please notice we're in free fall on the moon, and so on the moon it's not negative 9.8, it's negative 1.67 meters per second squared on the moon. So just notice that. 11 is good. 10 is good too, I guess. Ooh, I like number 12. I like number 12. I like number 12. You can cross out 13A, but certainly 13B is fair game. Free fall. 13C is fair game. 13D is fair game, and 13E is fair game. Okay? And for you guys, the answers do appear, right? Next to each question, or no? Yeah? Okay, because I had some situations because it was a weird ink that it didn't print for some reason. Nothing new today. Today is work on the review, finish the review, and I will be around today after school if you have any questions. I'm not doing a formal tutorial, but if you have questions, if you need help, come on in. Really though, sorry, before I look at the quizzes that we've done. Those are probably what I use to make up the test, or vice versa. I use the test to make up the quizzes, or the quizzes to make up the test. Okay.